Welcome everyone to today's open lecture here at Mid Sweden University. So today we're going to talk about 5G together with my colleague Aamir. And if you have any questions during this presentation, you can use our Menti code. So go into menti.com and use the code 8623 8699, and then you can get and write your questions during the presentation to Aamir, and then I will ask them. And we will have a short discussion in the end. So this lecture is also part of a course on 5G that we're starting now, that you are also the teacher in. So I will talk a little bit about that in the end as well, about this course following up this. But with that, I think I leave it over to you, Aamir, to talk more about exploring 5G on the basics and beyond. All right.
Thank you, Stephen. Thank you for the introduction. Okay, the basic idea for this lecture was just to develop the groundwork for the upcoming lectures that will be given by the industrial experts. So in this case, basics, I meant like more what are the drivers, what is the motivation for 5G technology and what has been driving it. And then beyond, we look into different technological components of 5G. And then we also introduce some 5G related research and innovation activities that are going on at Mid Sweden University. So briefly about myself, my name is Aamir Mahmood, and I'm assistant professor in a research group Communication Systems and Networks that is under Computer and Electrical Engineering at Mid Sweden University. So briefly about the outline, as I mentioned, I want to introduce the drivers behind 5G and how we have evolved to 5G technology and what is going on beyond that one. I will introduce some 5G use cases and then go into what was the basic 5G principles based on which it is built on, and what are the main technological or the key technological components. And then I go into some activities, research activities at Mid Sweden University, and introduce some projects around that. I will conclude my talk, and after that I will give a quick overview of the upcoming sessions by the industrial experts, and then we can have a Q&A session. So let's look at how the mobile communication or cellular systems have been evolving, starting from 1G to 5G. And it's not stopping at 5G, and we are going beyond that when people have already been talking about 6G. So if we look at the first G technology that was introduced approximately in 1980s, that developed the foundation, that established the foundation of mobile telephony. But it was not common for common use. Even the mobile terminals, they were quite bulky and suited more for inside the vehicles or inside the homes. But based on that, then the mobile telephony was introduced for everyone when 2G was introduced after a decade. So if you see that the evolution is from 1G to 5G, the evolution is happening, new technology, G is coming by every decade. So mobile telephony for everyone was introduced. It was more digital service, SMS, MMS based services. After that, 3G came in approximately in 2000, and that developed the foundation for mobile broadband. The data was more in focus, and we have the more voice and data more in a digital format. And then in 5G, then it's enhanced. We get high quality services, broadband services through 4G. That's not only that, but it also introduced, because IoT trend started at the same time, so it introduced narrowband IoT and LTE M categories to serve the massive IoT scenarios. Then now when we talk about 5G, that's we usually call the real digital transformation is happening, and we envision a real network society. Why I say that? Basically, if we look at what these generations had impact on the different industries, because so far it was human were in focus, voice communication was in focus, or some broadband services for different applications. If we see the impact, first, really had impact on the industrial applications, and in 2G, then of course by using SMS, machines could send messages with each other. That was the early stage machines talking to each other. And then in 3G, then of course video monitoring could be used for surveillance kind of applications and remote access to machines. And then 4G, as I mentioned, massive IoT was in focus, but also high quality video streaming, gaming applications were introduced. So now in this, then when we say 5G, you need to consider that at the same time, other cellular or other wireless technologies are evolving that are more LoRa, long-range communication, then at the same time, Zigbee, Bluetooth. Those technologies were evolving and they were serving different applications in industrial domain. Now, what 5G did, it really brought the transformation in terms of giving a unified platform to provide all these kind of services. So what 5G introduced, three services. Of course, it was mobile broadband, but more enhanced with higher data rates as the capacity demands have been increasing with time, with new kind of streaming applications, the gaming, online gaming, cloud gaming applications. But at the same time, then it's not only the capacity, the data-intensive applications or throughput-intensive applications. At the same time, we see that connectivity at the larger scale for massive IoT devices. For that one, it introduced massive machine-type communication service. And then there are some applications in the industrial domain for vertical industries, basically that require ultra-reliable and low-latency communication. So briefly, it's called URLLC. So those are more latency-aware or dependable communication applications. And then, of course, we are not stopping here. 5G is still evolving, and people have already started talking about 6G. So if we see latency versus bandwidth for these, as we have evolved from 1G to 5G, initially in 1G, when we were providing basic services, latency was not that big issue. It could give a round trip time from UE to the base station, 800 millisecond latency. But as we evolved until 3G, it was reducing by half. But now, when 4G was introduced, because of the online gaming applications, latency requirement was much tighter. So it's promised up to 10 milliseconds. Because I'm introducing that concept earlier, because in LTE, there's a frame size of 10 milliseconds, and one slot is 1 millisecond. So round trip time, frame to frame, it's approximately 10 milliseconds. So it could have a latency of 10 milliseconds. But what 5G did is introduce flexible numerology, where you can schedule on a finer grail on a mini slot level, so that you could have a round trip time of 1 millisecond. Here I mean round trip time. Let's say a UE is communicating with the base station, sends a command, and it gets the response within 1 millisecond. And on the bandwidth or the throughput, if we see, we started at 2.4 kilobits per second, but now we are approaching to 1 gigabits per second. That's what 5G is promising, maybe even more. And that is like, if you can compare it with the earlier version of Ethernet, that was providing 1 gigabits per second. So we are reaching quite high in terms of capacity and throughput. And then, as I mentioned, 5G is not stopping at what it promised. It's evolving continuously. So it's built on capacity, reliability, and connectivity premises. So introduce three services: MMTC, eMBB, and URLC. And now we have already reached to a point where we are calling it 5G advanced. So if we look at the new specifications coming from 3GPP, new features and new use cases are targeted, and then now we can call it eMBB plus or URLC plus. So the triangle is basically expanding, and what you need to consider is it's not this fixed triangle, because there could be some services that would be at the intersection of eMBB plus or URLC plus, requiring low latency but at the same time higher throughput. That's one project that I will show. That's the use case where both low latency is important as well as higher throughput. And then when we move towards 6G, then you can see that it's not any more a triangle. Now we are more octagon, or that kind of, we are expanding in all different dimensions to introduce new type of services and to serve new type of use cases. For example, if we look at the LoRa, it's integrated communication and localization and sensing. Basically, that's a new feature where we want to use the same network for sensing as well as for communication. And then as we are growing in this octagon, the network complexity is increasing. So one important thing we need to consider is more like zero-touch network management to introduce the network agility as to to address the dynamics of the networks. Then on the different sides, we could people are talking about XR, AR, VR kind of applications, tactile and haptic communication, and then if we consider uplink heavy kind of applications where the video feed is going towards a remote operator and he's taking an action on operating a machine or a vehicle. So it's going in different directions, and that's where we see that the 6G vision will be realized. So as I mentioned, who is developing these specifications, and based on those specifications, standardization is done for cellular technology. It's 3GPP, third generation partnership project, and they started with these specifications of 3G technology, and all these new features, they come in different releases. So for example, in case of 5G, the 5G started approximately in 2017 with release 15. That's where EMEB, URLC, and MMTC services were introduced. And then in different releases from release 16, 17, 18, in this case, the 5G specifications are as new services are introduced, the 5G technology is evolving. And now, starting from release 18 and 19, it's already called 5G Advanced. And with that new services, where we see that the role of AI ML for RAN automation or using AI ML for air interface optimization, it's already introduced. So at the same time, if you see starting from release 19, the new requirements for 6G are being gathered, new use cases are envisioned, and then it will continue. And if we see this specification process, by 2030, it's expected that there will be a commercial launch of 6G. So when we look at the 5G use cases, here we call verticals. Earlier it was more human-to-human communication and applications around that one. Now 5G is targeting different industrial sectors. So here I have listed down 5 more into manufacturing. Manufacturing is one important vertical for 5G, where it's process automation and the manufacturing, where 5G could be used together with wired technology to serve this mobility-related use cases in the industrial environment. One is the remote robotic control that I will also go into one project that we have been doing. Then energy and utilities, it's more grid monitoring, smart grids, where fine-grained control and protection monitoring is needed, or it could be any other example where we want to monitor production systems and analyze it. In the public safety domain, of course, the earlier applications for IoT and 5G has been smart city applications. Surveillance is important, and if we want to monitor any critical infrastructure, then we need to, the 5G is a good candidate for that. In healthcare, of course, all these personal health systems and telemedicine, where remote surgery, for example, is considered a critical use case for 5G. And then in public transport, where we are going towards more like V2V, vehicle-to-vehicle communication, future autonomous vehicles. For that one, that's laying the foundation for communication between the vehicles and the infrastructure to control. So what were if we look at the 5G key principles, as I mentioned, is the data intensive or bandwidth intensive applications, where the examples are video streaming, augmented reality, and virtual reality. Low latency, here when we talk about V2V communication, autonomous vehicles, remote surgery, and any real-time gaming. And industrial control, for example, is another low latency use case, and massive device connectivity. That is for IoT applications in general on the larger scale, on the city level. Then if we look in a different dimension, it's having more flexibility in managing the 5G networks, where the software-defined networking and network virtualization is an important feature in the core network side, to have dynamic network management and optimization, where the the service demands are changing dynamically, or the device that are connected requiring that service are changing dynamically. In that respect, network slicing, when we want to support heterogeneous network, we can define end-to-end network slice to serve, for example, EMAB service or URLC service. Then energy efficiency, it's, from sustainability point of view, it has been an important thing. In addition to that, it's because for massive IoT applications where we want to have a battery life of maybe for up to 10 years. So then 5G introduced different energy saving techniques for that purpose. In addition to that, I would like to mention the figure on the right. It's about the reduced capability devices, where some applications, wearables, healthcare-related applications, we don't need maybe high bandwidth, but still we are latency aware. So then 5G introduced reduced capability, RedCap. It's called RedCap, reduced capability devices, where the throughput peak data rate demand is not that high, and we want to save the energy. So it's simplifying the receiver design on the UE side. Spectrum efficiency. Spectrum is also a critical aspect in any technology, and 5G has been looking into the efficient use of the spectrum. For example, at the last bullet where it says that 5G has to work in conjunction with 4G, together with 4G. So for that one, the figure in the right is showing two different options where 5G could be working as a non-standalone manner together with the LTE, where it has a separate data plane, but the control plane is through this EPC, the evolved packet core of LTE, or it could be in a standalone mode where 5G data and control is happening separately to the UE. So for those things, spectrum efficiency here, 5G introduced dynamic spectrum sharing, where it could share the same frequency resources with 4G in a dynamic or in an opportunistic manner. Here I sketch the main 5G technology components. It's a lot to see here. I could try to sum it up here. And then I will be introducing some of these one in later. It's more flexible numerology, as I mentioned before, giving to provide low latency services. It allows to schedule the UEs on a mini slot level. Then it provides different deployment options. Now, for different enterprises, they might have different needs for 5G. So it might not be that the whole solution, 5G solution, is deployed for let's say a smart factory. Either we could have different options. We could have different options to play around those features to find the right trade-off between service quality and the cost. Then, of course, on the physical layer, the multi-antenna technologies have been advancing, where distributed MIMO is considered for scheduling the multiple users on different beams. New spectrum is introduced for 5G, which has, for any technology, it's a critical component to have the access to the right spectrum. Then software-defined networking to ease the management process of management as well as the scalability of the new services. Network slicing, spectrum coexisting, as I mentioned about the dynamic spectrum sharing. And if I go on the other side, if we want to introduce 5G for critical industrial automation kind of applications, over there, we need to consider that the TSN, time-sensitive networking standards, a set of standards are being developed. They want to harmonize the field communication with the IT. So to have a single technology that could provide both best effort traffic as well as deterministic traffic. And then 5G sees this opportunity to, within a TSN network, how to serve this mobility-related use cases. Then, of course, positioning, starting from release 16, 5G has been introducing new architecture, new protocols, new signaling techniques to increase the accuracy of the positioning over cellular systems, where it started with 50-meter accuracy, and now it's already, with release 19, it's aiming for in the order of centimeter positioning accuracy, and especially in the indoor environments. Then if we see on the bigger level, AI/ML has a role where 3GPP has already been looking into to optimizing the air interface. But in all these areas, AI/ML is going to play a role to optimize the service or to fulfill the quality of service and quality of experience requirements. So here I will go touch on some key aspects of the 5G spectrum allocation. So if we see in this figure, if we the band is divided into low band, mid band, and high band. So now low band is, if we consider into one sub 1 gigahertz band. In that band, if we look at the properties, okay, now with the smaller frequencies, we can reach to longer distances. We provide the wide area coverage. But then we also need to consider the bandwidth is limited, so the capacity is limited. So that's a use case that is maybe more suitable for massive IoT applications. And then if we consider the mid band, that's 1 gigahertz to 6 gigahertz, it provides the decent coverage as well as the capacity, and also could provide low latency services. And then in this respect, what 5G is considered a prime band for 5G is this 3.4 gigahertz to 3.8 gigahertz. That is harmonized 5G band in EU. That could be used on a national level, but in addition, 5G also different countries have introduced local some portion of the bandwidth that could be used for local industries. And then on the other hand, in UK, then it's the shared use of that spectrum. So we need to consider spectrum access could be licensed, unlicensed, or it could be a shared use where different technologies are accessing the same medium based on some cognitive radio concept. So in that case, the mid band is, precious band, where both decent coverage and capacity could be provided. And then 5G, of course, here, if we should see how different technologies have been allocating the spectrum. So 5G in the orange color, where I have shown that how the spectrum is allocated for in different bands. And then here you can, as we go for higher band, it's more millimeter wave or terahertz communication. So then, of course, the distance up to which we can communicate or get the high capacity is very limited. So it goes for more shorter range communication. Then, as I mentioned, 5G provided different deployment options to have a private 5G network. And in 3GPP terminology, it's called non-public networks. Public network and non-public networks. So in this case, we could have 4 configurations. On the left, if you see, if the whole 5G solution is deployed in a factory environment, so that's a more like standalone private network, pure private network. So in this case, just take a note of this control plane, data plane, and the management. So based on the distribution of this control data and the management functions, we could have different deployment options for 5G. So then on the left here, when I put these dotted lines towards the public network, so it means that the radio access network is shared with the public network. But then how we distribute this control and data plane, that depends. That these providing different options for the industries to how to play depending on their requirements. So in this case, when we have the control plane here and data plane here, so it means the data doesn't exit that premises. So in this case, some enterprises, maybe they're concerned about the data privacy and they want to protect their data set. It's more proprietary information. So in that case, this might be, although we are sharing the radio access network with the public network, but the data doesn't leave the factory. In the second case, shared RAN and the control plane resides in the public network, but the data is the local data breakout or mobile edge computing, you can consider that. So in that case, data doesn't exit the factory, but the control. So now if the number of devices are increasing and then they have, for the control, they have to go to the public network, then maybe it will be a bottleneck. So then those kind of things we have to consider. In the third case, it's completely hosted by the PN, by the public network, but the management, basically, it remains in the control of that premises or that factory or that environment or that enterprise. So based on this one, we could have different deployment options. And then we also need to consider, I mean, as I mentioned here, of course, the solution cost is increasing when we have a dedicated private 5G network. Although we could have more guaranteed performance, but then you need to assume that maybe that enterprise is not well trained to operate this private network. On the other hand, if we look at here, there might be we have more dependency on the public network, and then there could be data privacy and security concerns in that case. Then, as I mentioned, the networks are becoming complex. We need more zero touch with minimal intervention from the human to maintain and optimize the operation of these networks. So that's where the target is, and it's expected that the AI/ML will play a big role to improve the automation process. Here I put one example of network slicing. Network slicing itself is a critical component of 5G, but let's assume that we want to serve this mobile broadband, massive IoT, and the critical IoT. Critical IoT here, I mean URLC kind of applications. So in that case, we could have an end-to-end slice, but just consider that if the devices are I mean, radio propagation conditions are changing, or their traffic demands are changing, or the number of devices that we want to serve in a slice are changing. So in that case, we have to dynamically adapt the end-to-end resources. So for that one, we have been looking into elastic slicing, for example. Going further, as I mentioned about the TSN, time-sensitive networking, and we see that in a factory environment, we could have different use cases where where 5G makes a good case. But then those cases, we need to consider that they might not work independently. So they have to integrate with the existing TSN network, the industrial standard for a wired standard for communication. But in future, when we talk about smart factory, it's we want to have a more flexible production, where it's not monolithic, static assembly line. Rather, depending on the demand and the product needs, probably we need to change that assembly line. So in that case, if we want to integrate bring in some different manufacturing unit. So within that, it's quite hard to configure those wired networks. So in that case, 5G makes a good use case to realize the concept of smart factory. So here I painted, if it is TSN, we need to consider that from a TSN perspective, we have one talker and one listener end-to-end. Those are the two entities that are communicating, and then in between there could be the switches. So what 5G is coming up with is basically becoming a transparent bridge to that TSN network by introducing the time translators on both sides, and then such that this 5G itself becomes a bridge to the bigger TSN network. And then on this scale, then of course we have to do the translations of different traffic profiles, traffic services, and the kind of features that are provided by TSN. Here on the right side, the different standards for TSN are given. And then in parallel, I have tried to see what are the latency, reliability, and resource management features that 5G has introduced in order to provide these kind of services by TSN. So here, I mean, it's a long list to go through, but it's flexible numerology, mini-slot scheduling that I mentioned already. Then we could have uplink and downlink preemption to preempt the ongoing packets. That was already also provided by TSN with frame preemption. Reliability, if we look at the reliability, of course, new modulation encoding schemes are introduced in 5G. Multi-antenna techniques, they also help in achieving higher path diversity and reliability, and macro dual connectivity. You can be connected to multiple base stations. And then, of course, here on the core network side, 5G also introduced packet duplication, and that was in response to what TSN had, a frame replication feature. Resource management, we could have grant-free uplink transmissions, where it's not always needed to establish first control and then the actual transmissions are happening. So we could have a grant-free kind of uplink transmissions. On the scheduling scale, it's semi-persistent scheduling, where we could have more scheduling in a deterministic way for the critical services. And then, of course, time synchronization. TSN networks, they heavily rely on the time synchronization feature, and the 5G introduced new signaling as well as new features to have time synchronization over the air interface, which has been a problematic aspect in depending on the line of sight or non-line of sight conditions in the indoor environment. And so it's this time translators, basically, they are doing the translation of all these features from TSN to the 5G and then back to the TSN domain. And then on the resource management, how the resources are configured, that is this application function that deals with the TSN controllers to provide these services. If we look at the positioning in 5G, starting from release 16, the basic positioning architecture was defined and new signaling types were introduced, where one key component is the location management function that is in the 5G core, and that handles how to provide the resources to the UE to localize in the uplink or downlink direction. And of course, there are the traditional ways to how this localization is done based on different measurements, where enhanced LID is used, multi-round trip time. From multiple base stations, you calculate the round trip time and the intersection of that time-based or angle-based. Then there are new angle-based time difference of arrival, angle of arrival, departure kind of measurements. We can do the positioning. But to achieve the centimeter level accuracy, the new feature that is 3GPP is looking into the carrier phase estimation and using that together with these existing measurements to improve the positioning accuracy for different use cases. So we started here in release 16 with the accuracy of 50 millisecond, and then how quickly we want to localize a UE, for example. It's in the order of seconds, 30 seconds, for example. But for the critical use cases now, it's already the requirements are reducing in the order of tens of milliseconds. So we want to localize the UE quite quickly and on a finer fine grain localization for example, this kind of tracking of assets and driving applications. Then, as I mentioned, AI ML in 5G, it's a quite big topic. Here I just could say that how AI ML could be utilized in 5G. If we look at this figure, then of course on the physical MAC, radio resource management and deployment level, for different functions, we can use AI ML. Here, one distinction is we are using AI/ML for optimizing the wireless network instead of optimizing the application. So that's what we have to consider. So whenever we see that we cannot accurately model a problem that we want to solve, or it's too complex to solve explicitly, so then in that case, AI/ML makes a good use case in that case. So at 3 levels on this highlighted box, if we consider AI/ML, how it could be used. It could be used for developing solutions. For example, I want to look for appropriate modulation encoding scheme for a certain scenario, how AI/ML could come up to a right solution in a given environment. I could use it for that purpose, or I could use AI/ML in local algorithms on the device level or on the base station level. For example, the beam management or any kind of independent task. It could be used either on the UE level or on the base station. Or it could be used together when we have some cooperated task between the UE and the base station. So that it's a non-local model that spans over network and device and learning this task together. For example, this CSI in the uplink and downlink direction. So I will now move towards more what's happening at Mid-Sweden University related to 5G on the research and innovation level. If we look at the research, I mean, we have been touching upon these topics where network automation or RAN automation is an important task. We have been looking into elastic slicing. We are doing resource allocation for ULC kind of services. We have been looking into indoor sensing and positioning, and then network intelligence, where we want to have dynamic network management and optimization. And then, of course, this research, based on this research, we are contributing in different projects. We built on this research to get different projects. The project that we have been doing is next generation industrial IoT, where we want to provide more deterministic services over wireless networks. Then remote timber, that is 5G for teleoperation. I go into that one later. And then it's a continuation. Remote timber 2 is the more continuation, where we are looking on the bigger scale, where network slicing, mobile edge computing, and different RAN architectures could be used to build a robust wireless infrastructure to provide this, to serve these challenging use cases, for example, teleoperation. And then we have recently kickstarted this 6G, ensure 6G. But if we see that, okay, it's a continuation 5G to 6G, there's a thin line where we define the boundaries, where we have been looking into connectivity in the rural areas, especially in the northern part. So here is a bigger level overview of this project, 5G for teleoperation. We termed it as remote timber. 5G in general have been considered in the sport automation, construction automation, mining industry, and here we are looking more into the teleoperated forestry. So here the example use case that we had, when the wood is fallen in the forest, then the wood is usually transported to a timber terminal. So our objective was to automate the operation of this timber terminal, so that a remote operator sitting at a remote location could operate these wheel loaders for different various tasks, offloading, storing the wood, and then loading it again to the trains or other transportation trucks when it's going to the industry. And here, related to that one, I have a short video. If you so this this is in Sundsvall, Torsboda, a timber terminal, where this the wheel loader is working, is operated by a remote operator, although sitting next to that location. But you need to consider that the traffic, all this video feed from this the wheel is going to Stockholm and then coming back to the operator sitting in that area. So this is the operator having multiple uplink video feeds. So this was a quick overview of that one. Okay. Then we learned many lessons from this project. It was a single vehicle working in a confined area. And in addition to that, we had a quite much over-provisioning of resources. Using both LTE bands and 5G bands, we had the carrier aggregation, different FTD and TDD kind of thing. And then even in that confined area, although, I mean, we need to consider that we had a single base station. So, and then from the application point of view, we had strict latency and throughput the bandwidth requirements. So then we did different tests in even if we move beyond a pile of wood, then we see that we were violating those latency constraints, or even in the non-line of sight condition, we were not able to satisfy this 50 megabits per second throughput for multiple video feeds. So based on that one, we learned many lessons, and then we went to further, and we got a new project from Vinova, where all this Ericsson, Telia, SCA, so both the operators and the enterprises who are looking into this forest supply chain, we are working together to improve the performance of 5G network. So that, I mean, it's just one vehicle, maybe multiple vehicles, if they are operating in the same domain and they have high uplink video feed, then can we serve that feed in that by that network? So here is the continuation of that project. As I mentioned, then we have been looking into different RAN architectures. We are looking into network slicing and how we could use the help of MEC instead of sending the raw video from the vehicle to the remote operator. We want to do more object detection and sending only the necessary information to the operator that could help him make the decisions in driving. And then, of course, here is the interesting use case that we are looking into this using drones to provide the coverage holes. As I mentioned, this Boda kind of timber terminal location where the wood is stored, it's always dynamically changing. And then we can easily have whatever network we deploy in that scenario. It might be line of sight or no line of sight. So we might always be into that kind of problem. So using drones or UAVs makes a good use case over there to whenever a UAV is out of the coverage, maybe using MSE, we could position the drone in an appropriate location so that we have the access to that machine. And then here is the Ensure 60. Just to give a quick overview here. The objective is, I mean, we are going further into that supply chain. We want to monitor this supply process, monitoring of this transport infrastructure in the northern areas where the conditions, very snowy conditions. So in that area, we want to have integrated remote sensing and data coming from different sources. We want to integrate it together to monitor this industrial logistics supply chain. And then, of course, in the rural areas, the connectivity is a problem. Here, I have one picture of Starlink. Even if you consider on a bigger, if you see that all the other Europe is well covered by Starlink, but in the northern areas, you will see very sparse constellation of the satellites from Starlink. So here in this project, we will be looking into high altitude platforms together with UAVs to provide the coverage in these remote areas to provide different kind of connectivity requirements. So I reach towards my conclusions. So 5G, it shifted the focus from previous generations, more from human-to-human communication to machine-type communication. And it's targeting vertical industries, and it's paving the way for real digital transformation. If we look at the 5G NR, new radio, it introduced many enhancements on low latency, ultra reliability, and capacity. And that paves the way for integration with existing technologies in different industrial environments. If we see realistically 5G adoption, it's all, everyone is talking about the data, even the operators, that's what their main revenue stream is. But it's our job to find interesting use cases for 5G and then see how it performs and what are the possible enhancements. So as Stefan mentioned, so this is the first lecture of this course, 5G Fundamentals Applications. Here is a quick overview of the upcoming sessions and speakers. So there will be 4 lectures. We will go deeper into 5G and its applications. From Ericsson, we will have a guest speaker. Then, of course, it's important to know the operator's perspective. We are researchers and the technology developers, we always give a different perspective, but we need to hear from the operators as well, what they are thinking and where the future is and how we should develop this 5G or 6G technology further. Then from ABB, we will get a critical perspective on the role of 5G for industrial control systems. And then we go further into network architecture and deployment aspects. That ends my talk. So we are open for question and answer session.
Thank you very much, Aamir. So you can change to the next slide. So if you have any questions for Aamir regarding his 5G presentation here or 5G in general in the future, I guess, you can write them using our Menti. So it's menti.com and the code is 8623 and then 8699. There is probably you've probably seen the QR code during this presentation as well. So please go in there and write some questions for Aamir. So like Aamir said, this is part of a course or almost 2 courses that we will have on 5G. So, so this was sort of like the first lecture in this first course on the fundamentals of fundamentals and applications of 5G. And these courses that we have is in this concept that we call driven, which are courses aimed towards working professionals. So they are very flexible, made to be taken while you're working at the same time, and made for wanting to know more about these interesting topics and stuff like that. And these courses are 3 credits in length. They are on the most level, and since they are university courses, they are of course free of charge. And if you want to find them, you can, easiest is to find them on our website for the Driven project. So www.mion.se/driven. You will find all of our Driven courses for working professionals there. And there you will also find links to apply for this fundamentals and applications, and also the follow-up course on 5G technologies, which will be sort of like a little bit more in depth on the technology side of the 5G side. Things. Of course, you can also find these on antagning.se, and there you can search for spring 2024, and then it has a code there for which is MIU D2282 is the code for this specific course. And it's if I remember correctly, it's still open for late applications. You can still apply to come in. I think it's only open for 1 more week, because after that you guys start with the regular lectures and from the guests and stuff like that.
First lecture is on 29th.
Yeah.
Yep.
So if you want to jump in and listen to these interesting talks from the guests that you have invited, so please go in and join the course. And I think that formally, to be admitted to the course, you have to have a bachelor's degree in engineering or in engineering degree or equivalent. All right. So like I said, please write some questions if you have some questions for Aamir. So. So let's we can start with some of these questions. So one of the first questions we got here was regarding security. So how secure and robust would you say that 5G is?
Oh, well, from the encryption point of view, since after the 2G, the cellular technologies, they have been improving in terms of securing the communication, so no one can hear it, as compared to the first G, where everyone could hear you. So, I mean, that point of view, the communication is secure. I mean, of course, there could be some ways to still tap into some calls, at least for security agencies, for example. That's there. But if we look at the 5G security, then they have been introducing different, for example, network slicing. They have been introducing different authentication and encryption mechanisms so that no one can access that slice, for example. So that new features are introduced into 5G.
Yeah, all right.
Then, but in general, of course, as it's more AI ML is introduced into the system, and the different services are introduced for network management or operation. Of course, the security threat is increasing, and then there has to be separate activities around that one to work on that. Yeah, there's always a room to.
Always room to improve.
Yes.
The question there also the question: what happens when the BTS is broken? So could you expand on that? So the BTS is the.
I mean, of course, and at a given point, a UE is connected. I mean, within the hearing range of multiple base stations.
Okay.
So if one BTS is broken, then of course you can connect with the next one, whoever is in the coverage. So usually operators, when they design this RAN, do the drive test based on that one, they provide the coverage overlapping. So in case one BTS is down, then it will maybe reduce the capacity of that area, but you will be served by different BTSs in that area.
Right. So from a more sort of student perspective, how would you say, like, what is the most important parts to remember from your lecture and to know about 5G going forward?
Yeah, it's knowing what has been driving 5G and based on what features basically 5G is built on, and what was the motivation. So then framing those features to different application domains. So that's important. And then, of course, knowing the 5G, it's slow and long process. I mean, understanding how the RAN, radio access network works, how the core network works, and then how they work together. And what are the new features that are introduced into the core network side.
So what would you say is like the biggest, like of these verticals that you talked about? Which one do you think is very like the killer case for the future for 6G? And
if I see from different activities from big vendors, Ericsson, Nokia, Huawei, they have been pushing more into the manufacturing industry. But then, of course, or the smart grids, for example. But nothing is out of the scope. Like, yeah.
All right. So how about the energy efficiency then? So how would you sort of how energy efficiency is 5G? And like you talked about these IoT devices, will it work for everything in the future? Or
well, for mobile broadband, I would say the same energy efficiency. There is no significant improvement. But on the other case, when I mentioned about the reduced capability devices and the massive IoT devices, then of course energy efficiency is increasing, and now 3GPP is looking more into the wake-up radio, where the radio is not always listening to the control signaling from the base station. Rather, it is waking up when there is a certain message. But in addition to that one, they introduced different power-saving modes, where the UE is not always connected to the system.
Okay. Connected to that also, we also have a question regarding like 6G and hardware. So so when the technology reaches 6G, how can hardware adapt it? Do we utilize the hardware systems like non-standalone 5G, or do we need to build a new architecture, stuff like that? Is 6G gonna be like a build out on top of 5G that we can use the existing infrastructure, or do we need to rebuild everything?
As we are moving in 5G, it's more like softwareized architecture where you could use the same. I mean, it's a software that you could have on a general purpose hardware. So that's where the future networks are evolving. So,
right. But will it be the same on the client sides, or do we?
Yes, client side would remain the same. I don't know if we want to make it more programmable and how.
So the final question we have here then is so is there going to be any potential role for like service management and orchestration, SMO, in 5G and 5G advanced?
In that respect, I mean, ORAN, Open RAN is coming into the picture, where we want to have a multi-operator kind of radio access network. So in that case, SMO, of course, it will play a big role.
All right. Good. So again, thank you very much for your presentation. And I, again, just want to remind everyone that if you want to listen to the follow-up presentations from Ericsson and ABB and all of the partners that we have invited for this course, you have to apply for this course and join in on this short course aimed for working professionals. All right. And that's it from us from today. So thank you very much, Aamir.
Thank you. Thank you.